Hello everyone, we are team number 1. Isn't it time to implement telework culture and let employees work from everywhere? Aside from already known reasons, remote working style could be solution for some current issues regarding city development. For example, the pandemic situation, it is just one of the problems. How efficient do you think rental office use? According to survey in US, desks are empty during 40–50% of normal working hours. Depending on industries, 70% of people want to work remotely at least once a week. In this regard, we propose telework office solution. Many business analysts, current situation is not good for business, so many urban problems comes out from urgent urbanization. For example, during the peak hours, traffic congestion increases and citizens waste time on the road instead of enjoying with family or friends. There is no way to find out how strong impact would be, but one thing seems to be clear. Working remotely is helping many companies and individuals to deal with urban issues to control the situation. It contributes to reduce traffic congestion, build green environment by reducing motor vehicles, support startup companies by offering flexible and cheaper facilities, improve employees' time management and increase productivities.
Next we introduce the telework project framework. The global community experiences the importance of technology as a tool and a response to emergency situations such as COVID-19 pandemic. Referencing to New Deal, a Korean project with a pillar to accelerate the shift toward digital economy and the aim to foster non-face-to-face industries by promoting a remote work especially to small and medium-sized business as an approach to sustain their labor market. Improving the productivity and efficiency of employees by adopting the concept of telework requires a strong collaboration between different entities. A generic framework to implement telework project is proposed and consists of different layers, from identifying the goals and the objectives of the project for the benefits of community with respect to smart city perspectives. Considering the key performance indicators of the city where the project is to be implemented will lead to identification of the real problem to be solved. The next layer focuses on generating a model that will be used to achieve the goals and objectives of telework projects and to solve the identified issues. It will also list out the requirements, the collaboration needed or stakeholder engagement, project financing and referencing to other cities where a telework project is being implemented. The final layer of the framework entitles the feedback from the community as central to city intelligence. The human activities, innovation, opinions and participation will influence the policy reformulation such as work flexibility to encourage teleworking activities. The decision makers are requested to reach a consensus with the community on smart urban development, and the process will be repeated continuously until all the goals of telework are achieved. Public sector is supposed to initiate and encourage the private companies and the citizen to adopt the shared, integrated telework facilities. The requirements to implement telework project differ from city to city but include acquisition of resources such as ICT infrastructures. The high-speed internet network 5G can facilitate the customer's satisfaction, and it will allow the facility users to access real-time data directly from their physical offices without any delay. The companies should also provide virtual private network VPN service to their employees to ensure the security of companies' information. These resources are not limited to cloud and hosting services, software, and other physical infrastructure such as space, furniture and human resource team. This project can bring solutions to cities that experience high congestion and traffic jam. Bangalore, a city in India, ranked the first city with high traffic jam globally. The telework project can contribute to help employees work from more near home, generally to save traveling hours from work to offices. This project also is feasible in Kigali, a Rwanda capital city where the employees are expected to start a job at 7 a.m. Morning activities such as taking kids to school etc. are a big challenge to respect working hours, and we imagine that telework solution can help efficiency by reducing morning stress. Next we will explain the telework specific plan for Shihung Smart City. This project encounters 5 steps for developing telework model in Shihong City. First, diagnose and define the key point aspects of cities, citizens and governments. We believe the following few points are potentially problematic: COVID-19, traffic jam from more to workplaces, overcrowded population, real estate cost, environment and so on. Next, it would be to set the vision and mission to resolve the pain point. We are contributing to reducing traffic congestion, building a green environment, supporting startups, increasing productivity and managing city risk. And third stage, this project sets up and categorizes crucial key values. There are many values to make the telework model fully operational, and we will find the key values. For example, technology and financial capability. This project will develop a phase milestones and roadmaps for implementation. At that time, we will study any benchmarking models and make own prototype model and operation. We will match the model into Shihong Smart City ecosystem and keep the sustainable telework model. For the milestone, we need to keep the roadmap in mind. There are 4 phases about the milestone of telework model: preparation, growth, leap, complete phase. And the end goal is to build a sustainable teleworking model that balances technology and citizens of Shihong Smart City.
In order to successfully complete this task, we must set the criteria for self-evaluation. First, sufficient investigation is required to successfully complete this task. This idea needs to be creative, it needs to be related to smart cities. In addition, it is necessary to check the feasibility of the project and whether it can be applied to other countries for the final goal. That's all our ideas so far, and we'll try to put them into shape.
Hello, we're Group 2, presenting about waste management strategy named Farewell and Throwwell. My name is Sungjae Park, and we have 4 other members: Shinu, Chonggang, Kin, Suolat, and Jihuan. Many of you know that Korea has been leading recycling area. Yes, that's right. But as you can see, we are the second in the world. But is that true? But these numbers are not recycling rates. It's just a separation collection rates. So, according to Ministry of Environment in Korea, only 30% of plastic can be recycled. Then where are the 70%? Until the moment I read this article, I could not believe that Korea is one of the countries shipping garbage to overseas. So this is how Korea treats the rest of 70% of waste. But what makes it worse that China and Vietnam, those countries has been importing garbages, and we are producing more waste every year. There's no other option. There's no other place to bury in Korea. So reducing and recycling are the best options we have. And I wanted to see how SNU people, like students, doing. So I literally dig in the trash cans in 35 dong. Well, as you can see, there are only 3 cans labeled, and inside was not really organized yet. And there's a paper, the plastic and the general waste, cigarettes and paper, a carton of the milk, and the plastic here. The plastic again, and then later there's plastic bottle. They didn't empty the plastic bottle, and also the paper they should be put in the different bag and cans. So it's not very well. So we have to. So we found a problem in our campus, and we try to focus how other smart city try to solve this problem. So first case is Barcelona. They made a color code for each types of waste and trash can. And trash can has a pedal for people to open it easier. And other trash cans are collect waste through underground pipes, which is very useful in Barcelona because they have really narrow path. So this takes less space. Mm. You can check the location of the trash cans and temperature around it. And the for from this Barcelona case, we should be able to answer these following questions, like for sustainable waste management strategy. Second case is the Singapore's pig belly trash can. It uses solar energies to compress trash and provides the Wi-Fi to people. So the trash can itself can act like a platform that connects the other devices or sensors. And they installed it every 500 meter along the walkway, so which is kind of useful. In Korea, there's one startup company called Superbin. They created the machine called Nephron. It not only collects the recyclable waste, it also collects the images of waste in order to build a big data. And they make profit from the waste and return this back to users. I think this is very nice business model. So we can summarize the advantages of smart beans, and we believe that those beans can bring us more than the collecting the waste. Um, I think our group is still on the brainstorming stage, and we roughly drew an outline for of our solutions. The first one is the institutional solution. The extended producer responsibility (EPR) is the system of waste recycling of the share responsibility among the producers, retailers, and consumers by funding the waste management system and collaborating with the local government. The benefits of EPR are more products out of the disposal. The projects redesigned it more durable and more recyclable and less toxic. That creates job and the cost saving for local government. Mm. The Korean government it introduced it EPR system in 2000 that strengthened producers' responsibility from the production stage up to collection and recycling. EPR system is applied to uh, four packaging materials like lubricants, tires, fluorescent, fluorescent light bulbs, and batteries and electronic products. And the and other like two other solution can be support the stable operation of recycling market through close price monitoring and proactive responses, and they invest more in innovative recycling technologies. Like a few days ago, LG mm, invented like like biodisposable plastic. So it can be like one option. Yeah. The second solution is about how to solve this problem with technology. The ultrasonic sensor can measure the amount of the waste and send this data to the center. And then the Information of waste amount can be visualized on the map.
Chapter 4 is Management Solutions. We believe SNU students will solve the waste problem in our campus. We have prepared a mobile Living Lab platform for students to participate in this campaign. A Living Lab is an intersections of scientific innovations. A Living Lab is a user-centered, open innovate system, often operating in a way that integrate current research and innovation process within a public-private people partnership. Living Lab are natural site of convergence, bring together different approaches to solve real campus problem. Mobile app Keda was student-made Living Lab platform in our campus. Keda integrate with real-time monitoring system, and data is collected from students and their mobile device, and processed and analyzed to allow campus officials to interact directly with the community in order to enable a better waste management in campus. The additions of citizen science byproduct, smart citizens, in this case a smart student, could strengthen the relationship between citizen science, smart campus, and living labs. And smart citizens make it possible for living labs to flourish through their science and cultural literacy. Until the end of this semester, through the Living Lab platform CADA, we will identify the distributions of some campus trash and collect some new idea for managing it. Thank you.
Team 3, and we're discussing about the urban mobility, digitalization, introduction of mobility as a service, MAS. Our agenda is the following. We start with the introduction, and then we see the project framework, then the project plan, and in the end we see the references. First, I will give the introduction. So what is MAS? It is a service that integrates various means of transportation, such as cars, buses, subways, and bicycles, into one platform. It has characteristics such as integration of transport modes, one platform, customization, journey planning, traffic packages. On the right side, you can see our prototype app. As you can see, you can search the way to define a destination. You can choose your preferences of mobility. With that means of mobility, the app will show you the most suitable way to get to the destination according to the user preference of fastest way, cheapest way, shortest transfer. The user can book all the means of transportation and pay all at once. Here's the overview of the project. The two case studies of MAS. By researching the global case of smart cities, several solutions can be included to overcome barriers in proper market penetration of MAS in Korea. Then there will be two ideas of MAS. By implementing the proof of concept of MAS in terms of mobility and data in Sihong, the feasibility of MAS could be examined and verified. Two key values, mobility and data, are chosen and termed as follows. Then there are two cities of practice. After the trial and error, developed MAS system could be implemented in Seoul and Incheon City. Seoul and Incheon have the largest number of population and trips. Sihong will act as a moderator between the two cities. In the end, there will be a business model plus implementation strategy, and then a prototype will be explained in a later slides. So what are the project goals? First, it is possible to reduce the continuously increasing traffic congestion by increasing the efficiency of transportation. Second, it is expected to increase user convenience and promote shared and complex transportation means. Third, it can contribute to leading the technology in the field with element technologies related to 5G communication, big data, blockchain, autonomous vehicles, etc. And continuously enact relevant laws and modify regulations. Fourth, it is possible to revitalize local tourism resources by introducing integrated mobility services to tourist destinations. Here's the first case study. For this, we refer on the world-first mass app implementation called Ubigo. Ubigo's goal is to develop and implement a ticket system for all public transport tickets, combining public transport, car sharing, rental car services, and taxis. It offers a flexible monthly subscription, and it was implemented first in Gothenburg, Sweden. Our second case study is about WIM. It's an all-inclusive mass solution. It is implemented as an app for smartphones. It offers an all-city transport service, including public transport, taxis, bikes, cars, and other options. WIM was originally created for Helsinki, Finland. Now it's spread all over the world. So what does our business model looks like? First, the platform provides customers a reservation and payment system. Customer pay before or after using transportation on the platform. Second, the platform provides the customer's reservation data to the transportation companies and charges instead of customers. Moreover, companies send traffic and sensor data to the platform for charge and services. Third, providing transportation is not enough to maintain platform. Get additional funds from third party. Advertising, contract, and sell data will be the main fund source of this platform. So, what is the proof of concept? We can prove the concept of mass applications through our 4 changes that will happen in the field of mobility. First, it is a one-step service that allows the use and payment of various transportation means at once. Second, the public transportation system is improving access to cities and reducing traffic congestion. Thirdly, the road system will change with the introduction of autonomous vehicles. Lastly, with the development of vehicle sharing systems and public transportation systems, the concept of individual vehicle ownership will change. We will prove the concept of mass applications through 4 changes that will happen in the field of data. First, an integrated data platform will be built to collect data through various means of transportation. Second, it is possible to analyze the integrated transportation system that will changes in real time through real-time monitoring. Third, it will become a transportation environment with the introduction of autonomous vehicles and shared vehicles. Fourth, the digital twin can be applied through the integrated data platform, and as a result, urban environmental problems such as traffic and pollution can be solved. It is a strategy for building the system according to the timeline. The overall strategy is distinguished to under third and over fifth year. From the first year to the third year, the Sihuang test bed will be mainly applied. After the plan will be stabilized, a strategy will apply to expand it to Seoul and Gyeonggi area from the fifth year. The following is a detailed plan of mobility and data over time. In the mobility sector, from first year to third year, mainly regulations, transportation method, application, system construction, infrastructure construction, and laws are established. From the fifth year onwards, plans from the establishment of an integrated system will be expanded and infrastructure for regional connectivity will be established. Also, law for each region is established. In the data sector, from first year to third year, the scope of application of sensors to collect data will be expanded, and an integrated data platform will be established, and a system to adjust it will be established. It also establishes law on data construction and use. From the fifth year onwards, we will establish a connecting platform and payment system for big data application and expand to surrounding areas. When looking at the transportation options of each city, Incheon has a lack of public transportation compared to Seoul. Particularly, there are only 4 subway lines in Incheon, but there are more than 10 lines in Seoul, showing a big differences in accessibility to public transportation. There was no significant difference in purpose operation for each city, but the proportion of home vehicles in Seoul was high. It can be interpreted that the proportion of visitors to Incheon is higher. Seoul has relatively good ITS, its intelligent transport systems, and mobility, and through MaaS, an integrated platform can be formed. In Incheon's MaaS, it is considered an urgent priority to increase the efficiency of ITS and public transportation, which is insufficient through big data analysis. The status of transportation system is metropolitan area in Korea is as follows. Collecting and providing information on various individual means of transportation such as buses and subways, introducing the integrated public transport fare system early on. Third, good conditions to introduce integrated transportation service. All kinds of transportation systems shown in the slide will be integrated in one app. The slide is the specific usage, assuming a user who want to go from Yongsan to Kaohsiung. When user would use the app, we would use the app in Seoul. There are many options to the destination, including minimum price, minimum time, and express tabs, and also offers various transportation options. This slide assumes a user who wants to go from Yongsan to Chengdu, China. When user use the app, there are options beyond the national territory to the destination, including ship and airlines. Before we move on to the specific app usage, we consider data-driven analysis system first. First, data-based marketing and promotion system, which is analyzing data collecting by each user's traffic routine. The platform app will provide promotions and service for each specified user. Second, Sihong is our testbed for the mass application. Third, when user use the app in Seoul, complicated and various types of transportation system will be merged in the platform. Big data from million users can be collected in Seoul. Fourth, compared with the user in Seoul, when user use the app in Incheon, integration means not only in a domestic but also outside in a territorial border. Incheon is one of the growing international hub cities, which the airport and harbor are located in. This slide shows the requirement for our plan. First, collect data. Collecting data by sensors installed in each autonomous vehicle and vehicle sharing systems, and real-time response to urban problems through real-time monitoring and prediction systems of urban environments using digital twin platforms. Second, integrated transportation system. Build an integrated data platform by accumulating data obtained through various means of transportation, including public transportation. So there will be 7 criteria for self-evaluation, which are: first, data collection; second, cooperation of existing transportation-related companies; third, reasonable rewarding system for both participants of development and users; fourth, security of personal data information; fifth, establishing data center and incubating the expert personnel and companies; sixth, governance, independency of local government, industry, school, government, cooperation. Seventh, considering platform application UI and UX accessibility. Thank you. This is our final slide, which is the references. Thank you.
Everyone, my name is Jisoo, and I'm in Team 4 consisting of 5 members including Marcus, Youngun, Ramuna, and Tohi. And today, Marcus and I are going to give a brief presentation on our concept note. Urban concentration has brought a number of problems including lack of housing and infrastructure, traffic congestion, and unemployment. However, expansion of infrastructures is not a long-term solution, but only a temporary solution. On the other hand, smart city is one of the most realistic solutions to such urban problems. The use of IT technologies, which is the background of progressing the smart city construction, not only improves efficiency and productivity of the city, but also enhances urban sustainability and competitiveness of a city. IT technologies can be used in various fields, including platform technology, smart buildings, smart transportation, smart energy, smart water, and smart government. But our team is particularly interested in electric road system in smart transportation and water supply management system in smart water. So our main project goal is to analyze how smart city solutions can be applied in real-world cities. First of all, we are conducting case studies in the field of smart transportation and smart water management system. Then we are going to analyze the applicability of the smart city solutions in SNU campus and TN Smart City based on the current status of the technology, business modeling, and technology commercialization, as well as regulations and legislation. And we are also going to derive the expected effects obtained by applying the technology. Lastly, we will examine the implementation of the smart city solutions in two global cities, Tel Aviv in Israel and Brasilia in Brazil, based on SWOT analysis and PESTEL analysis. For our case studies, we have selected the case of electric bird system in Sweden. Sweden is the world's first to adopt the electric bird system that recharges the batteries of cars and trucks traveling on it. With the aim of making the country's transport sector completely independent from fossil fuel by 2030, there are currently 4 ongoing demonstration testing ERS on public roads in Sweden. All 4 demonstration projects utilizing either overhead lines, conductive rails, or wireless technology. These projects are primarily funded by the Swedish Transport Administration and aim to demonstrate and gain more knowledge about ERS. We are particularly looking into the Evolution World project, which has been implemented in the city of Lund, Sweden, by the Swedish Transport Administration in partnerships with industry, academia, and the public sector. They are using wireless communication to identify electric vehicles driving on the road, and power is transmitted from 1 kilometer long segments directly underneath the vehicle. The power can only be supplied through the rail segments, where the pickup receiver installed in the vehicle is able to connect with the rail and receive power. And since the power is completely turned off in other areas of the road, this type of power transmission is safer than other types of in-motion charging systems, making it suitable for both cities and on highways. And the electrified road is being trialed using electrified trucks that have been developed as part of the project. And another case is the water management system in Paju, which was initiated by the Korea Water Resources Corporation, simply known as K-Water. It is an integrated water management model covering the entire water cycle with the aim of improving the water quality of existing waterworks and ensuring the stability and safety and efficiency of water resources at the regional or city level. The Paju Smart Water Cycle project gathers GIS and real-time data, gives the opportunity to focus supply and demand, as well as analyze the water quality. The project consists mainly of 2 programs, Dr. Pipe and Net Operation. Dr. Pipe is a water pipe diagnostics program which uses performance evaluation and diagnostic software to promote technological realization of the preliminary diagnosis post-improvement policy, proposed to perform maintenance and improvement of the water pipe network more efficiently and reasonably. It supports the establishment of an optimal network improvement plan based on the diagnosis and evaluation of pipeline information, repairs, water quality, and facilities. Whereas Net Operation is a water network operation management program which consists of modules including real-time pipe network analysis, water quality, crisis and energy management based on GIS and real-time data, water pressure, and real-time leakage monitoring and leakage estimation.
For the implementation in SNU campus, we divided it to smart transportation in Guana campus and smart water management for C-Home campus. For the implementation, we will research the current state of electric road system technology available, analyze and propose a business model for technology commercialization, understand the SNU transportation actual system in Guana campus, the current policies and the legislation that it is in use. We will also understand applicability, analyzing and writing the expected effects in the city for the future. For example, the Guana campus shuttle bus run from 8 to 19 o'clock every weekday, within 6-kilometer road every 4 to 7 minutes. If after changing to smart buses, it is expected to the level of CO2 emission decrease at least 1,200 kilograms of CO2 in a month. Also, the possibility of charging the electric cars that use Guana Campus Road would be considered as a business model. For Sihon Campus, the implementation of water management system needs to be understood. How is the actual situation and the possibility of integrate the smart devices for real-time measuring, automated technology and monitor devices, smart integrated solutions for flood analysis and control system, weather forecasting, pipeline network operation management system, use of big data services, and shared two-way data to reflect the consumer's need. The global cities selected for the implementation studies are Tel Aviv in Israel and Brasilia in Brazil. Tel Aviv shows many traffic congestion problems that cause environment pollution, threatening the health of the citizens. Brasilia has an artificial lake, but its dry season is strong with around 111 days without rain. The smart water management can contribute to the 84% of the water consumption made by the residential area that suffers with shortage of water imposed by the local government, by the only water supplier and a private public company. The project plan has milestones to be reached as shown in the graph. The main goal is to reach success by implementing the whole solution. We expect the electric road system to be implemented in the near future, increasing the quality of citizens' life, enrich the city panorama, shifting from fossil fuel to electric, eco-friendly solution, reducing gas emission, air pollution, and the noise in the city, generating sustainability, safety, and a greener city. In the water management, we expect foster smart utility by promoting sustainable use of finite resources, providing cleaner water, reducing the cost of maintenance, and prioritizing the citizens' higher quality of living. Thank you and see you in a near future.
Hello, this is Group 5 and we will present our concept note. The project title is Smart Passenger Allocation. Our presentation includes case study, introduction, theological background, and project plan. First, we will share two cases related to our project. One of the cases is smartphone service in Japan. The app provides the congestion status divided to 5 levels, as you can see. Using the beacon and mobile devices, the system can detect how many people are inside each wagon. Next one is smart metro system in Seoul, showing the real-time information of crowd status. Using a sensor, the system detects weight of the passengers and then they can calculate the crowd level. In summary, the two cases might be useful to mitigate congestion of subway, but the system still have some limitations, including information for an available seat for pregnant women or how much the wagon will be crowded after people waiting for the next one get on the subway.
Great. Moving on to the foundation of this process, this project, we looked at Seoul Metropolitan's Rapid Transit System's yearly reports, where they outlined the core vision and the core goal of organization. Firstly, the vision is for a people-oriented, pleasant, and convenient transportation system in Seoul, which then builds upon the notion of the goal, where a faster and more convenient system is at the center. So based on these two, we were able to look at what is the result for us? How can we achieve this through the implementation of smart city understanding and smart city concepts? And that sort of entails itself into our core question, which stands at the foundation of our project, being that of how can we, through utilization of real-time passenger IoT data from both inside and outside the metro, arrive at a more pleasant, convenient, and smart journey for the individual. So in order to understand this concept, we have to look at the problem itself. So why has this vision, this goal not been achieved yet, or how can we achieve it to a larger degree? Well, the first problem is that of size. The metro system in Korea has, to date, 7.5 million average daily users, making it one of the busiest and largest systems in the world. This number even increases to 8.8 million during the peak times on Fridays and Saturdays, which is 170% of the daily average. Secondly, the notion of the people-oriented transportation system. So people have a mental agenda in that they tend to stand at the first entry point of the first wagon as they enter the metro through the stairs. So people don't really spread out. And secondly, there's a lack of information surrounding passenger capacity. And all of this summarized arrives at the notion that we don't really believe it's a question of capacity, because the metro can handle a lot more individuals. It's more a question of allocation. So what are we going to do about this problem? Well, firstly, as we mentioned earlier, is that through active visualization of IoT sensor data, we believe we will be able to know how many people are in each wagon, how many people are waiting outside each wagon, but also, and more interestingly, how many people are waiting at the previous stations leading up to yours. And through all of this, combining this data, we'll be able to provide a real-time and way more actual representation of what your chances are to get a seat and how the density is in terms of passengers in each wagon. So the system is threefold, meaning there's three subsystems that together form the whole. First of which is the screen. So as you're walking down the stairs to the metro station, you'll be presented with a screen that shows you how many people are in each wagon. And this number is achieved through looking both at passenger count inside and outside the wagon, but also how many people are at the previous station leading up to yours, as I mentioned before. And then it's going to provide you with a concrete, specific suggestion. We suggest you go wait in front of 4.1, as doing so would increase your chance of getting a seat and having a less crowded metro.
So the second sub-solution is the LED indicator. There will be LED panels along the entire platform and display color codes which represent the passenger occupancy level in each part of the approaching metro. It's a graduate color offered a refined analysis of passenger load and could be converted into a comfort level. Passengers will tend to move efficiently toward colored zones that indicate the best level of comfort. Moreover, when a train is in the station and the doors open, sensors located at each door count the number of people entering and leaving the metro. When the doors close, this data is processed and converted into a comfort level that's sent to the following station to be displayed on the screen. So next, the last sub-solution is the LED waiting indicator. The predictive information of carrying capacity will be shown on the LED waiting light. It predicts the occupancy level in combination of current capacity of wagon and the number of waiting passengers. So it will provide the reference information for passenger to choose the better waiting line. In addition, passenger also can follow the LED guideline for better and faster in and out of the subway efficiently without block traffic.
This part is theoretical background. The goal of the project is to provide a more efficient and comfortable transportation system for subway passengers. To achieve this, we need to identify three major components of a smart city. First is the technology component. We use ICT and big data to secure data applied to our project. In order to secure this, sensors that collect data and technology that process data in real time are required. Second is the human component. In order for our project to work properly, we need to identify the problems people are feeling, and we need to make sure that people are aware of the usefulness of the project we plan to use. Source is the government component. The government provides necessary data for this project and participate through investment infrastructure. The most needed resource for this project are data and sensors that can collect data. It also needs an algorithm that can process real-time data collected through sensors. Each subway platform secures data by detecting the number of people waiting and the number of people getting on and off the subway. The analyzed data will not only utilize real-time data, but also existing data to provide information to people. In order to provide the obtained results to subway user, a smartphone app that is linked in real time and a display board of the subway are required. Next. PPP will be very important part of implementing our project. The Seoul Metro, which is the public sector, will provide investment and data for infrastructure in the process of this project. The private sector is telecommunications company such as SKT and KT. The telecommunications company will analyze the collected data and produce the results and provide the results to passenger and the Seoul Metro. Revenue realization in the public sector includes transformation costs and reduced vehicle traffic due to improved public transportation. And in the private sector can expect more data to be secured and publicity effect.
So next is our project plan. We have 4 stages: conception, prototype, data collection, and implementation. In the conception stage, we listed out the problems that can be solved through smart city approach, and we have decided to focus on the problem happening in the metro station, which is inefficient passenger allocation. In prototyping stage, we'll build prototype and check the demand of the passengers or their reaction regarding the smart passenger allocation system. We may conduct real-world testing in small-scale station like Duncheon or Sindap, collecting data and applying experimental prototype in the stage. Moving on to the next stage, data collection, we will collect real-world data in bigger stations like Gangnam or Jamsil. And finally, we will move on to the implementation stage, which builds applicable minimum viable product. So our milestones are as followed. First is empirical on-site research. We should observe passengers' behavior and gather empirical data of how passengers move in the station. Second, we can conduct demand research. And third, we will operate our test workshops to see whether the value of smart passenger allocation systems are successfully delivered. And last milestone is data access and data collection. And in this stage, we should care about the privacy issue. This is our reference, and this is the end of our presentation about smart passenger allocation system. Thank you for your listening.
Hello everybody, this is team 6, me, Sangjin, Sinku, and Zubaida. Our topic is identifying locations of public shared bike rental facilities using a case study and internet text mining. The idea is how can we utilize SNS and digital content to develop a better suggestions for locations of the facilities using text mining. So the outline of our project is we'll go through the background of the topic and then discuss the purpose and review the method and the contents of our project. And then we will see the expected impact and effects. Please, yeah. The growing urban population puts more pressure on policymakers to develop innovative mobility solutions. Traffic congestion is on top of those challenges cities are facing, wasting a lot of time and people stuck in traffic. Moreover, increasing the environmental pollution, including noise and carbon emissions, not to mention health-related issues and coexistence with other species. Flexibility is also another challenge for urban mobility, especially for residents who live far away from public transportation routes, making their first and last mile inconvenient and time-consuming. Therefore, the first and last mile transportation can be an area of innovation and business model. The global market already seen a growing demand for bike sharing. The graph on the left shows the increasing demand in the United States for different cities, according to NACTO, and on the right, the figure depicts the global market growth in bike sharing as indicated by Credence Research Incorporation, and they predicted that the potential growth of a rate of bike sharing market annually is nearly 12.5%, referring that the market of such business is. So what exactly this adds when we talk about smart city? WHO defined smart city beyond just high-tech city, providing the concept of healthy and of healthy cities, encouraging policymakers to put health of citizens as a top priority. Therefore, aligning bike sharing solutions to the United Nations Sustainable Development Goals 3 and 11, which consider good health and well-being, should be taken when designing mobility solutions. And this also can contribute towards building more sustainable cities and communities. So what SNS and text analytics and mining has to do with bike sharing now? As we know that connectivity has empowered the voice of citizens, letting people easily express their opinion, more effectively allowing communication channels to collect data on citizens' needs and perception and respond accordingly. In SNS, large volume of text and data contains very valuable information that can help design a better location and quality of service. For example, extract opinion and analysis of sentiment expressed by individual comments referring to a particular bike sharing scheme, issue, any suggestion or feedback related to that facilities. And in the next part, my colleague, Mr. Sangjin, will tell you more about the purpose of our project. Mr. Sangjin, the floor is yours.
Okay, Mr. Sangjin. This is the purpose of the project. So, as already mentioned by Mohammed, as the market for personal transportation sharing services has recently split. And so the safety issues such as traffic accidents and conflicts among road users have been raised. As shown in figure and table, the main problems are maintenance, management, and safety. So therefore, a multi-perspective approach is needed to solve these complex problems. So in that respect, our research team first grasped that the lack of facilities and placement in an appropriate location is the beginning of the solution to the problem. And we tried to research to solve it. On the other hand, Seoul prepared a standard for operation of private shared bicycles for the first time by local governments and signed an agreement with Mass Asia in November 2017 to start a pilot project. So in this study, we would like to refer to a project in Seoul, and we make the target site as Seeing City. As a study shown in figures, with consideration of the accessibility of bike sharing spots and various facilities existing in Seeing City, so we propose to find and select the proper locations of sharing bike. So next is the Sungu.
Yeah. This chapter will introduce the contents and methods of the project. First of all, this project consists of 4 main frameworks. First, we plan to collect priority research and issues on the project topic. A literature study will confirm the role and importance of shared mobility, especially shared bicycles. At the same time, we will set a direction and purpose of the specific project. The following pictures are excerpts of some of the papers and articles we collected during the pilot studies. The next step will be to collect examples of public bicycles. In this course, we will first investigate the current status of the public bicycle business in Seeing cities and find problems. We plan to investigate domestic and foreign public bicycle businesses, classify them by characteristics, and investigate the procedure for selecting rental facilities for each project. Through this, we will select a suitable public bicycle operation model for fields where the business has not been activated. The third step is to derive the location characteristics of the rental facilities through various data. In this course, we will select location characteristics in three main ways. First of all, we will derive the universal location characteristics of the rental facilities by utilizing the paper and literature related to the location of the shared mobility rental facilities. At the same time, our group will conduct a density analysis of public bicycles that rental facilities operated by Seoul and other cities to derive location characteristics from the overall area. Finally, we will find out the location characteristics of rental facilities that the customer prefer by crawling through social networking sites related to public bicycles and posting on the city official claim sites. These 3 methods will construct the location characteristics of the rental facilities, and the next step will be to leverage local data to derive the respective location of the rental facilities. In the final stage, we will collect local data based on the location characteristic of one indicator built in the third stage of Seeing City, and use GIS to derive the expected location of public bicycle rental facilities. We will then select 2 other cities that have not adopted public bicycles, and we will look at them in the same way. And then next, Jubeda will talk about the expected effect.
Now, let's look on the expected effect of bike sharing. First, we conduct a SWOT analysis to know if the project is feasible to be implemented in Shihan City. The proposed project will provide convenient transportation at a reasonable price. The strength of this project is availability of transportation gates from subway stations and awareness of people on the benefit of bicycle riding to their health and environment. Availability of bicycle infrastructure, integrated card which can be used for bike renting, availability of security camera which can be used to monitor the bicycle in the city, and availability of policy which can govern the adaptation of bike sharing are the opportunity for this project. Although there is some weakness and threats such as funding issue for implementation and monitoring costs for bikes. Also, the project implementation requires approval from different departments. This project is feasible to be implemented in Shihan City. The bike sharing service market is expected to grow from 2.7 billion in 2018 to 5.0 billion by 2025, at 10.2% compound annual growth rate during 2019 to 2025. This project will increase business activity for both business and customers due to increased accessibility within local neighborhood and shared bicycle stations. For personal health benefit and environmental sustainability, this project will reduce environmental pollution, traffic congestion, encourage a healthy lifestyle, and reduce expenditure on healthcare. This is some reference in our study, and thank you.
Good evening, everyone. Our team presentation is on smart air quality management system. We are team 7, and these are the team members using IoT and digital twin technologies. Next, in our introduction, next we will present the issues of smart city. And the smart city, we are focusing on air pollution and how to reduce this air pollution in smart city problems. So we are focusing on this green area, green parts of the smart city. Next. So in order to make the smart city sustainable, we need to use IoT devices to gather data in real time from sensors, and of course communicate this data for decision making, and analyze them to compute and make actions, and then finally act to transform it into the initiatives for environmental improvement, and of course behavioral influence and infrastructure optimizations using innovation centers. Next. So in IoT, as we all know, these are the very important. One of the application area is the air quality improvement or monitoring of air quality. IoT application is widely used. Next. So as per the World Health Organization, air pollution is the silent killer, and of course killing like 7 million deaths per year. And of course, across the regions, it has different figures, and this considered as invisible killer by World Health Organization. And next, the main source of the air pollutions are the industries and its energy supplies, the transport sector, and waste management, agricultural practices, and household energies and dusts are among the top contributors to the this air pollution. Next. So as a solution, the World Health Organization and other institutions recommend to invest in green efficient power generation, improve domestic industry and municipal waste management, and of course making greener and more compact cities with energy efficient buildings and other recommendations. So we are focusing on air pollution part. And next. So as a case study, let's see some 2 cases. Next. The first one is autonomous and connected vehicle for clearer air in UK, Accra, Project Accra. And this is proposed by the UK project, and it is implemented in Leeds City to minimize the effect of these connected vehicles and the gas generated by this across UK and worldwide by contributing poor air quality. So there are premature deaths of up to 50,000 deaths per year even in UK. Next. The project aims or the objective was actually to overcome these issues by implementing project allowing remote control of vehicle energies, allowing management to ensure running is zero emissions. As you can see from the trucks, zero CO2, NO2, and PM are indicated over there. And next. So in general, the outcome indicated that developed the product communication to enable the transfer between the vehicles and air quality sensor to decision-making engines, and of course, able to monitor and manage control the location of the duration of zero emission operation, plug-in hybrid and range extended hybrid vehicles within the city. This enabled next. And the second case is clear nasal filter personal wearable in India. This is mainly offered during personal nasal wearables and showed in laboratory to be implemented in our noses to reduce this dust particles and others for smart ways. Next. So this is the devices, of course, that we can use in our noses, and this has the industry results for filtration and the like. Next. So in general, the lab result is encouraging and showed a very important result, and hopefully it will be in the market in the short time. Next. Thank you, and my friend will continue.
Okay, so the idea, please, next. Okay, so the air quality of Seoul Metro is getting worse because of the much traffic and the urban daily life up naturally. So we need more oxygen to make cities having some quality of life. From the research, we have found out that air quality in the forest is much better than urban city, even in the same city. So this helps us research the best place to test such phenomena theoretically through measuring the air quality and its relation between trees and air. Next, please. So according to article, the urban park space has been measured and compared with the major city in the world. And we have found out that one single Korean city's mean space was 9 square meter, whereas the other having 2 or 3 times more, having the higher than us. Next, please. So normally urban park has many green spaces by including the big forest and trees. This has been regarded as a natural air purifier, whereas every home having such air purifier device to clean the air in their home, because we cannot have such large scale of a city air purifier. So it is very much clear that we should have many urban forest parks to make it clean the air quality and supply enough. This helps us research the best place to test such phenomena, theoretically through measuring the air quality and the relation between trees and air. Next, please. So until now, the urban park have not only been used as aesthetic spaces of urban landscape, but also provide cities with natural leisure and exercise spaces, as well as quantitative air improvement effect. By quantifying evaluation capability based on AI and IoT cutting-edge technology, it is expected to contribute to urban design standard through planting trees and securing parks when designing smart city in the future. And it is expected to have a large impact on the creation of related jobs. Our team project goal is improvement air quality in city. Next, please. So this is the project plan. In order to objectively secure the effect of improving air quality through the expansion of green infrastructure in downtown Seoul, an IoT-based carbon and fine dust measurement system will be installed, centering on the Seoul forest to secure quantitative big data for an year. As a result, air quality evaluation AI algorithms secured through the machine learning. Establish an air quality evaluation system for Seoul forest based on AI technology, and finally, quantitatively calculate the effect of improving the air purification capacity through urban forest in Seoul. Next slide, please. So this is the block diagram. IoT device with following structure will be installed in urban forest to collect and quantify data on the degree of air quality purification on trees. Furthermore, we believe that data analysis by type or size of trees will be possible through data analysis AI. Next, please. So we thought about how we can apply data measured by IoT device from the perspective of cities. We suggest applying this data to the digital twin process so that it can be used as much more actively. Next, please. So what is the digital twin technology? The digital twin is a technology that models specific objects in real spaces and collect data generated from them in a real-time simulation and analyze them in a various environment or conditions of a virtual space, derives optimal result and applies them back to reality. Okay, next, please. So how can you adopt data to digital twin technology? Sophisticated digital twin technology has the advantage of enabling optimized output production at low time and construction cost, and relieving the burden of maintenance costs through real-time monitoring. We suggest a smart air quality management system that combines data collected using IoT into digital twin technology. So using sensors, secure quantitative data on the degree of air purification in forest. Number two, data collected by IoT is analyzed by AI. Number three, using the analyzed data, the digital twin model will carry out and visualize simulation of planting environment suitable for the site. Number four is select the most efficient alternative among simulation and apply to the actual reality. Next, please. So simulation and visualization using digital twin technology. So during the simulation and visualization phase, the simulation result will be visible and will help in the decision making. The simulation of the creation of the plant environment in the digital twin model is carried out through the following process. Step one, select the target site needs to be improved after real-time air quality monitoring using sensors. Step two, simulate the plant environment at the target site based on data on the degree of air purification by plant. Step three, selecting an optimal alternative through the simulation results such as air purification level, construction cost, and the growth status depend on variable such as species of trees and the plant arrangement. Next, please. Okay, my friend will continue.
I will introduce about implementation. On the same day, we measured the air quality of Seoul and Gyeonggi at the same time. The air quality measurement figures were displayed on the map to explain air quality difference between regions. First of all, the place with the worst air quality turned out to be Siheung City. Based on the same time, the air quality was nearly 3 times that of Yongsan, located near Namsan Mountain, and Gwanak-gu, located near Gwanak Mountain. Based on the above results, we are going to propose a way to improve air quality using digital twin to Siheung City, where air quality is clearly bad. Next, please. The index for air quality is largely divided into 6 categories. The first green dimension means good, yellow is normal, and orange dimension means having an effect on the sensitive group and can cause harmful effects. The first red means bad, causing harmful effects on the patient population, and the purple means very bad. And dimension of 300 or higher in brown represent a risk, a level at which harmful effects on the general public. Next. We selected Siheung City, which has the worst air quality as the target site. This place has air quality dimensions that are almost 2 to 3 times worse than other parts of Seoul and Gyeonggi. However, this does not mean the air quality of Siheung. Even within Siheung City, the air quality is divided into bad and ordinary parts. In order to find out why, with a research theory that urban forests and parks in the city improve the air quality. It compares Siheung campus site and the areas near the urban forest in Siheung City. Next, please. First, the air quality of the Siheung campus site is about 147, which is unhealthy. This is more than twice as bad as Seoul National University's Gwanak campus air quality. Next, please. The reason why the bad air quality of the Siheung campus is because there are many industrial complexes near the site. The red point in the picture represents an industrial area near Siheung campus. There are more than 10 factories located, which seem to have had a negative impact on the air quality in Siheung. Next, please. In contrast to the Siheung campus located near the industrial complex, the target site has a number of urban parks, mountains, and forests around it, which seem to have a good effect on air quality. Next, please. Near the target site, a Raji mountain and many small neighborhood parks are located. The green points in the right picture represent a park in the city center. The reason why the air quality in the same city is significantly different is that the green environment has a positive impact on the air quality in the city. Next, please. Currently, the Siheung campus is still in the process of being built. Thus, the smart air quality system will simulate the atmospheric environment and the cost of construction. And it can reflect this result in the planning process to apply the optimal planting environment plan on campus to the actual site. Next, please. We have visited the Seoul Forest to have a chance to discuss with the staff member to hear their voices, where is the best place to measure air quality by using the IoT devices. So we are planning to measure the air quality from November this year. Thank you for listening.
Hi, this is team number 8. We are Sungin, Agus, Renee, Minho, and Songchan. As urbanization increases, cities today are facing unprecedented challenges. To keep the same quality of life in 2050, well-planned cities are required. Without proper cities infrastructures, we will have problems with congestions, water crisis, rapid energy consumption, pollution, etc. Things will layer up and everything may collapse. So smart cities came out, solving urban problems using technology. Drones are going to play a crucial role in the development of smart cities. UAVs are involved in a wide range of applications and functions in smart cities. So we're proposing Global Drone Innovation Center for smart cities, including Sihung. We found some country cases of drone solution. One is solution for Indonesia, which is disaster surveillance. Lying on the equator and the largest archipelago in the world, Indonesia has a warm climate and beautiful islands with a rich and diverse cultures, which is suitable for tourism. Despite of being blessed, Indonesia is so prone to natural disasters. Earthquake and tsunami are two of them, leaving people on the coastline in danger. Tsunami causes loss of homes, jobs, and even lives. Aerial survey with drone can map coastal terrains with 3D images. This spatial data can be useful for decision making. When the disaster doesn't occur with a good business model, drone can be a source of living. Drone can give a bird's-eye view of coastal panorama as a new tourism attraction. For resilience and sustainable development of Indonesia. The second case is solution for Rwanda, wildlife safari. In the past, the only way that animals would benefit people is through hunting, which is a one-way relationship. Today, because of ecotourism, both people and animals are taking benefits. Drones can take a unique view of aerial observation on animal behavior without disturbing them. Drones will be the perfect tools to observe animals with fast movement in a high place or too dangerous to get close to. Aerial footages can be an incredible breakthrough to promote ecotourism and giving a green sustainable development for the people and the natural resources of Rwanda. There are two other drone utilization cases that can be applied globally. One is a case of Shenzhen, China. 30 years ago, Shenzhen was a small fishing village. Today, Shenzhen has a population of almost 13 million people, a challenge and a good learning environment for a city planner. The city planner utilized drones to capture the data, which is much faster and available in 3D formatting. Sensor-equipped drone is used to gather data of airflow between building for vegetation placement, even directing the way of pedestrians. Traditional building inspections can be expensive and time-consuming. New drone technology can do many things in a safe and inexpensive way for a better city planning. Another global case is in Rwanda. Kigali, the capital city of Rwanda, is a modern and clean city, but outside of it, the infrastructure deteriorates fast. Medical supplies by nature need to on hand quickly. If a mother is bleeding out during childbirth, she cannot afford to wait 3 hours for blood to arrive. A company called Zipline is working to solve this problem with its fleet of autonomous drones. Each drone can carry up to 1.6 kilograms, which is about 3,500 milliliters of blood bags. With a fast deploy and can fly autonomously with a speed of 100 kilometers per hour. These drones are so important to Rwanda's healthcare sector, saving lives at the perfect time. Now we are making proposals for Siheung Smart City. The main proposer is Siheung Global Drone Innovation Center. Not only for the National Innovation System, Siheung Global Drone Platform should be able to provide services for other countries. Global Siheung Drone Platform offers services such as 3D map generator from drone survey, 2D images analysis system for on-demand case or specific system, real-time image analyzer for special real-time cases, global ground station operation, LiDAR, smart radar development and other drone equipment, business model incubation for drone utilization. The Innovation Center will work as The Innovation Center will function in many ways. As global drone education institution, it will provide drone flight training and issuance of qualifications. It will be a center of global drone technology development with drone automatic charging stations. It will also provide global real-time drone services. Our second proposal is drone for coastal and marine tourism. Siheung is located in the western part of Gyeonggi-do, including the Yellow Sea and its coastline. Shiheng Mudflat is a first-class ecological environment area where various animals and plants live. Shiheng is planning to build a national marine cluster, and drones can be utilized in this plan. Drones can be used for monitoring and responding to marine safety accidents, where searching for survivors and saving is very important. And drones can help smart response to marine pollution accidents and marine waste. They can survey on the route of marine pollutants, quickly identify the scale of marine pollution, clear blind spots on ship patrols, which can save manpower, fuel costs, and short patrol hours. Drones can work for streamlined management of marine life.
Ladies and gentlemen, on behalf of my group, it is my pleasure to present you our project entitled Silver City, where it described initiatives and solutions for providing a better lifestyle to elderly people. The presentation will follow the next 4 steps, starting from background and ending with information related to cities for practice. Let's start with the project background. Population aging is progressing at a rapid pace as the birth rate decreases and life expectancy increases, showing that the population over 65 years exceeds the 7% of the total population. Looking at the trend, the average of the OECD countries and Korea are showing an increasing pattern of rapidly aging population. While the number of elderly people over 65 years is on the rise, the active working age population is decreasing, leading the intensification of social problems associated with elderly care. The elderly people do not have many opportunities to work outside, having to live a helpless and depressing last years. Thus, welfare policies developed for elderly people have been focused on basic living security, but it is expected to expand to a service that supports healthy and interactive retirement. For that, technology is developing and supporting elderly activities. In advanced countries where population aging care has progressed first, the use of ICT is emphasized as a mechanism to increase the effectiveness of welfare services and solve social problems caused by aging. Now, it's time to present some global examples about elderly care. City4H project is a research and innovation project funded by the European Commission, which, having as main objective to enable age-friendly cities, especially designed for elderly people. The project goal is to create an innovative framework on ICT tools and services in order to enhance early detection of risks related with fertility and provide personalized intervention that can help the elderly to improve their daily life. The City4H project has been implemented in 6 smart cities as pilot, such as Madrid, Singapore, Birmingham, Montpellier, Leeds, and Athens. In this slide, we summarize some of those pilots in City4H project to look deeper on what they are doing related with the elderly monitoring systems in the city. We found that all of the pilots have their own goal and scheme system in terms of helping the elderly to improve their quality of life in the city, based on the city's characteristics or issues. For example, in Singapore, the project is focused in the elderly social activities inside community centers by monitoring their activities, reminding them if they spend less time in that centers or if they stay out of home later than usual. In addition to the direct support that technology provides to the elderly in their immediate environment, such as those described above, it is also necessary to consider other types of solutions that are similarly designed to provide a safer environment when the elderly increase their social activity outdoors. One of the factors that motivates sedentarism is the feeling of an unsafe environment that elderly people have outside their homes. Factors such as non-inclusive public information systems or traffic lights discourage the elderly from enjoying life outdoors, leading to a rapid degeneration of their physical and mental capabilities due to the lack of social interaction or contact with the environment. One of the first senses to disappear in adulthood is vision. In this way, the Netherlands has developed an effective solution to technologically correct this physical degradation. These are dynamic electronic billboards, which, using technologies such as GPS and the Internet of Things, detects the proximity of the elderly people and immediately magnify the size of the non-commercial public information. So, the elderly people are able to clearly identify the message displayed and thus have a better understanding of the phenomena that is happening around them. To encourage the elderly to live a less sedentary life, it is not necessary to develop technologically complex systems. We take as an example Sweden, where through the use of RFC technologies, an adaptive traffic light system was designed, which at the moment when an elderly person approaches a crosswalk, it immediately modifies its behavior, extending the time available for the elderly person to cross the street comfortably and safely. Initiatives like this can easily be replicated in various universal geolocalized societies, such as the city of Sihum in the Republic of Korea, where there are districts in which the population density of the elderly is high concerning other cities. Population in Sihum have been increasing since 2014, and from 2016, 4 new cities were started to construct, leading a dramatic population increase. By the way, as the population grows, the senior ratio is also increasing. In 2010, the senior ratio was 6.19%, but in 2019, it became 8.74%. When see the population by districts, we found that the Begot district has the highest population, but talking about concentration of senior population, the Sinchon district has the highest senior population, and the Walim district has the highest senior ratio. Fortunately, the senior welfare budget is getting low by the years. In 2018, the budget was 9,000 million won, and in 2020, it was 123,000 million won. The right side of the slide shows the number of senior welfare facilities and its ratio. Recreational welfare facilities are more than 50% of whole facilities, and at-home and residential welfare facilities are less than 10% of total facilities. Smart city technologies related to elderly's welfare shows that the Sihun City's 2013 Basic Plan promotes the CCTV expansion for monitoring the elderly activity levels. Other smart city services opportunities based on agreements with stakeholders include smart bus settler, smart pedestrian crossing, and IoT-based total care for the elderly living alone. In Sihun City, there are more than 10 smart city projects. Some of them are completed and the others are still in progress. Some of them are closely related to the elderly support. This is the case of the IoT-based Living Alone Senior Total Care project, where the role of technology is take care living alone seniors from anywhere using LED or multi-tracker sensors. If there are any problem, the system immediately calls to the emergency systems for their safety. Another senior care technology included in Sihun City's Smart City Plan is the Smart Healthcare solution. It provides health management service and personalized health guides using live log data in connection with big data centers and responds to emergencies through data analysis and expert feedbacks. The last senior technology included in Sihun City's Smart City Plan is Smart Police, concept in which intelligent CCTV and patrol robots equipped with dialogue functions perform real-time monitoring. The information collected, produced, or stored by the technology previously described can be processed and distributed to public or private organizations in charge of provide services in benefit for elderly people, warranting the information confidentiality and security. In order to provide the senior care services discussed in the above examples, additional roles, as well as telecommunication and information privilege for institutions such as police or fire stations, should be granted. We set Sincheon as our case adaptation location. The Sincheon district has most high ratio of seniors in Sihum. For our project implementing, we consider places where police, fire station, hospitals, and bus stops are dense located. The target regions where we will implement our smart city cases, such as City 4H or dynamic billboards, are marked with red circles. Test target regions were selected employing elderly density information combined with geospatial information of public services for locating the better places for implementing the proposed technology. Finally, here is presented information related to cities for practice. The population size of Korea, China, and Japan was 1.5 billion as of 2010, and this accounts for 22% of the world's population, being 28% of this population aged 65 years or older. In 2035, 3 out of 10 elderly people in the world are expected to live in that country. Korea is facing the problem of an aging society due to the fast aging process, but the individual and state preparations for aging are insufficient. Japan's aging population is progressing at the fastest pace in the world. Korea is showing a trend similar to Japan in the 90s, just after the peak of consumption of major commodities, entering the aging society and the production capacity declined. Located in Kashiwa City, Chiba Prefecture in Japan, there is a small city outside the metropolitan area, named Kashiwanoa Smart City. This city was in danger of extinction, but now is a self-sufficient city in terms of energy, food production, industrial development, and residents' health management. Here, for example, residents can check their health status in real time using a watch-type digital device. The data obtained is transmitted to the health center and recorded in the smart city management system. Health data are also provided to local government and preventive medicine centers so that local health services can be effectively implemented, thereby reducing administrative and medical costs. As such, it is worth considering the idea of transforming a local city in danger of extinction into a smart city. Existing smart cities made a lot of investment in metropolitan areas with well-established infrastructure, which was highly likely to lead to widening the gap between the metropolitan areas and the local area. However, if a smart city is made to solve the aging problem in a vanishing provincial city, it might cost a lot of investment right now. However, it is expected to reduce the burden of medical expenses and the elderly care problems that will come as future expenses. Thank you for your attention.
Hello everyone, we are from Team 10. Our team members are Kim Dae-hwan, Jean Lee, Elias Aloysum Shamba, Won Sok Choi and Siam Sul Arifan. On this occasion our team would like to present the Integration Orientation to Destination or OD Journey Platform, a new direction for smart mobility. We have 3 main parts in this presentation. First, we discuss the project context, baseline and objectives, then we also describe the framework, project plan and milestones. And finally we also describe some of the case studies we found. Let's move on to the next slide. The smart mobility sector is developing in many ways in South Korea by Data Dam Part 1 of the Digital New Deal project, and Eco-Friendly Future Mobility Part 1 of the Green New Deal project. The main technology and direction of those smart mobility are usually associated with middle mile, such as TAGO or transport advice on going anywhere, autonomous vehicles, ADAS or advanced driver assistance systems, AEB or autonomous emergency braking technology and etc. There needs to be an integrated smart mobility platform that all people can feel in daily journeys, which can be called a true smart mobility infrastructure. We have 3 big goals for this project such as: First, build a smart mobility infrastructure that can achieve the most reasonable OD or orientation to destination journey in the least amount of time to all people, pedestrian and vehicle users. Second, build a smart mobility infrastructure that minimizes gas emissions and maximizes the use of alternative energy sources. And lastly, focused on integrity, efficiency, and safety of infrastructure. Let's move to the next slide. In this section we will talk about the project framework, plans, and also important milestones. As we already know, in the real world, the types of people who travel are mostly divided into two classes such as pedestrians and vehicle users. The types of travel are mostly divided into three types like first mile, middle mile, last mile. And by designing and integrating an extensive integrated travel system for three types of travel by two classes each, we expect the orientation of destination travel platform to be for everyone who moves in the real world. In this slide, we provide two diagrams that explain the project framework. As we can see, the pedestrian integrated journey system is mainly focused on the development of micro-mobility, and the integrated journey system that is centered on vehicle users is mainly focused on parking management and parking lot detection systems. Congestion in cities, vehicles, challenges, road safety, environmental problems, and cost solutions to enable micro-mobility, smart mobility, from the first mile to the middle mile where public transport is located and vice versa for the last mile. A middle mile can be at a bus stop or subway station. First mile connectivity allows passengers to travel from their location to a bus or train stop, while last mile connectivity takes passengers from the center mile to their destination. Electric scooters rental, drop-off and pick-up extend the bus or subway service network. Using micro-mobility in the first mile and last mile allows people to use electric scooters which are environmental. So far we have done the conception of ideas, especially the project framework, and ongoing case studies. Over the next month, we will design an overall algorithm for this platform and plan on management and financial direction for this project specifically. Lastly, over the last month, we will design a prototype of this integrated travel infrastructure that is implemented in Seoul City, and for the implementation, we will draw up a master plan that applies to the actual cities. Then the important milestone of this project is, first, the survey to users who are expected to understand real-world problems and the direction of expectations. Second, case studies of each technology or element specific to the platform. Third, design the overall platform direction, from physical to management and financing. And fourth, making prototypes and real implementation, master plan. Let's move to the next slide. In this slide, we present some smart mobility cases around the world. The first case came from West Midland, UK, in a one-year micro-mobility trial. An estimated 81% of people in the UK own a car, which negatively impacts the environment and costs. The UK government is setting aside £2 billion from a £5 billion fund for cycling and buses, an emergency active travel fund for the implementation of a project that will enable people to return to work after the COVID-19 pandemic and push more people off public transport and towards greener alternatives. In June 2020, the United Kingdom announced the first nationwide e-scooter trial to take a 12-month leased e-scooter trial. Voi secured a contract in Europe for the West Midlands in partnership with Transport for West Midlands. And the main points of this project are: the battery-charged revolution comes into action today as the government makes it legal to drive on the highway, so e-scooters fit more into people's way of life today than cars, short trips. Voi will also launch an online traffic school for motorists. The second case came from Portland, USA, on the e-scooter pilot program. This program provides an e-scooter pilot program led by PBOT, Portland Bureau of Transportation. This solution is needed because they face urban problems that arise, including rapid growth and the need for people to move efficiently. The first pilot, from July to November 2018, a joint e-scooter that supports smartphones, arrived in Portland. The second pilot from 2019 until now. This pilot started out with fewer scooters but offers an incentive structure that allows more scooters to companies that support city goals. Then the extended technology is the parking application, Parking Kitty, which allows motorists to pay for parking and find parking availability remotely. They also make implementation plans in the areas of finance, data management and infrastructure. The effect of this adoption was that on the first pilots they claimed riders made 700,369 trips on 2,043 scooters. 34% of these trips were reported to replace car trips. As of the second trial, riders made more than 1 million trips on this scooter with 2,865 e-scooters from 5 companies. The third case came from National Taiwan Ocean UNIVs on drone-based parking lot detection. They apply an algorithm for drone-based parking spot detection. The drone can mark and encode parking areas manually. They also conduct training on background images and vehicle images depicted by drones. Finally, they evaluate and test the drone's depicted images. And the last cases came from Singapore on smart parking system. Singapore rolled out its Parking.sg application that is revolutionizing parking payment in the city. Users simply enter in basic information, such as vehicle number, car park code, and payment info, to pay for a public parking space on a per-minute basis. The app sends users notifications about meter status and enables people to view their full parking history. Motorists of all kinds, ranging from motorcyclists to operators of heavy vehicles, can use the app to good effect. That's all. Thank you all for being here today and taking the time to patiently listen to what we had to say. We wish you all a blessed day.
Hello, everyone. Today we're gonna introduce our team project. Our project name is Sihyung Smart City, with smart mobility, smart energy, and digital twin. There are 5 members in the team. Our backgrounds are all different: energy systems engineering, creative business processes, technology management, administrative law, and transportation engineering. So using our various knowledge and information, we really hope to make suitable smart city plans for Sihyung and other cities. So firstly, with this presentation, we are going to introduce and propose smart solutions to solve problems and challenges faced by Sihyung City, through examples of 2 cities, Amsterdam in the Netherlands, and Singapore. They have successful experiences in implementing different smart solutions for the benefit of their citizens. With the proposal of our smart solutions, we aim to improve the living standard of Sihyung citizens, through improving the mobility of citizens, by introducing effective digital mobility systems. This project also proposes to reduce energy consumptions and CO2 emissions of Sihyung City to mitigate related consequences faced by the city. On the other hand, we will also introduce solutions to improve Sihyung City data connectivity to enable future economic development and implementation of city management systems. We found that Sihyung City has many city problems like other cities. But we want to focus on 2 problems to be solved: transportation traffic problem and energy problem. The first problem is the transportation traffic problem. Gradually more people are coming from other cities to Sihyung City. As the population in Sihyung City grows, the number of registered motor vehicles also increases every year. Their working spaces are not always near their home. 47.21% of citizens commute to other regions away from home, 10.4% to other regions inside of Sihyung City, 7.95% to Seoul, 4.68% to Incheon, 23% to other cities in Gyeonggi-do. However, public transportation does not meet the demand of citizens. Parking spaces are also not enough. The second problem is the energy problem. Since Koreans use a lot of energy, carbon dioxide emissions are also among the top 10 in the world. In particular, among OECD countries, Korea is the world's #1 greenhouse gas emission growth rate, which is 3 times the global average. Korea relies on foreign imports for 95.8% of total energy, and energy imports are increasing every year. However, energy consumption in Korea is large, and the expected energy demand is also high. On the other hand, renewable energy, regarded as eco-friendly energy, is at a very low level. So, to solve these problems and make better Sihyung City, we will use other smart cities good solutions. This is the project framework. Firstly, case studies. We searched various smart cities and selected 2 smart cities, Amsterdam and Singapore. We will continue the case studies of these 2 cities. Secondly, site analysis. A field survey and literature research of Sihyung will be conducted. The third step is to plan for Sihyung smart cities. And then finally we will suggest our solutions and plans for other cities. Now, I will show you our project plan. This is the Sihyung Smart City Roadmap of Data and Mobility, which shows the timeline for each milestone. We first analyzed problems of Sihyung City related to data and mobility, so we categorized the roadmap like this. So, the ultimate goals of data and mobility are to develop digital twin-based integrated city operation solutions and smart mobility with a sharing system. The objectives of digital twin are, to identify city issues efficiently and automatically and to give solutions to the problems, and to make a sustainable smart city. The objectives of the smart mobility system is, to provide shared mobility service, and all kinds of transportation information, through the Sihyung Transportation app, such as bus train delays, real-time parking space availability, and more. We chose 2 smart cities for case studies. The first city is Amsterdam. Smart mobility in Amsterdam is shifting towards using mobility as a service. At a point where public transport fails to meet the demand, shared mobility services such as Viavan, Felix, CAR2GO and others picking up try to fulfill the need. The most important issue is to get from one point of the city to the other easily, by accessing a car, bicycle, scooter, public transport, or travel planner, and make the payment in a simple and integrated manner. Amsterdam's smart mobility system also provides data-driven solutions, such as the Municipality of Amsterdam, the Smart City Amsterdam app, the GoOV app. The Municipality of Amsterdam provides citizens collection of relevant data, called the data punt. It can be used to provide transport on demand. This service would be real-time, responding to personal preferences, and it is based on smart, up-to-date information. The Smart City Amsterdam app provides up-to-date information and figures, for example on train delays. The app and the Park Shark app offer advice on where to park, and the Misminiat app on departure times and distances to ferries. The GoOV app is used as a travel planner for people with cognitive disabilities. The Smart Mobility 2019 to 2025 program, aimed at making Amsterdam #1 smart mobility city, through provision of shared mobility services, that is affordable, inclusive, accessible, and reliable to everyone. Amsterdam also planned to reduce CO2 emissions to 0 in 2040. This project is known as Cities N. Amsterdam Energy Transformation Roadmap comprises initiatives such as greening of the grid, huge warm water network, virtual power plant, residential retrofitting, and smart grid. The Cities N project targeted to revolutionize Amsterdam energy sector, by putting the citizens first. The role of citizens in a smart energy city is not only limited as a consumer, but it changes to the production of energy. Soon they will take an active part in trading their own local and sustainable energy. The second city is Singapore. Singapore has a good smart city plan, but we more focus on digital twin. Digital twin is a virtual 3D replica of a real-world asset. In other words, digital twin is a software representation of a physical asset, system, or process, designed to detect, prevent, predict, and optimize, through real-time analytics to deliver business value. Singapore is known for its small size and high density. Since there is little room for physical experimentation, government officials need a digital copy of the city to test new ideas, and cope with continuously changing citizens' demand. The data obtained from the digital twin technology is either static or dynamic. Through the digital twins built upon diverse architectural and topographical information in Singapore is used to conduct pre-simulation to facilitate urban planning. The goal of Virtual Singapore project is to improve the quality of the Singaporean people, by providing capabilities such as virtual experimentation, virtual test bedding, planning, and decision-making, R&D. Citizens don't want just fancy and beautiful cities. The most important thing people want is, to make livable and sustainable cities. The left image is a picture of the current Siheung city. Siheung is a good city, but there are problems, especially the regional gap, because of not suitable transportation systems. And also, there are environmental problems related to the industrial complex. So through our Smart City project, we're looking forward to contributing to planning a better city for citizens and nature. This is the end of the presentation. Thank you for listening.
Before starting the presentation, let me introduce our Team 12. We had 4 meetings to decide on a topic. Each member was interested in transportation, energy, and resource management. So it was decided as the most common topic, sharing personal mobility. Among them, I would like to talk about making smart charging stations for e-bike and e-scooters. First, the table of the content is as follows. In this presentation, I would like to talk about 2 case studies and our SNU site analysis. First is the background of the study. We first need to know that sharing economy is growing due to expanding personal mobility. Looking at the table on the right, you can see the willingness to share by continent. Therefore, you can easily see sharing bicycle or scooters. However, sharing mobility is far from transferring public transport. It shows the lack of accessibility of public transport. In addition, the demand for sharing mobility is increasing due to traffic congestion and lack of the parking space. Also, let's talk about status sharing mobility in Korea. In Korea, each company has its own operation. Also, each service company has a limited area. That means you have to install the company apps every time when you use it. You cannot ride on the sidewalk and bicycle road. From December, you can ride on the bicycle road if you drive e-scooter limited 25 km per hour. And also they commercialize dockless sharing e-bicycle and scooters. So we can find some problem about the sharing mobility. They are not designated parking zone. So they obstruct passageway, and also they are difficult to parking depends on weather condition, like rainy snow. Furthermore, they have the risk of safety due to insufficient sharing mobility road. We are trying to solve this problem by making smart charging stations. So our goals are as follows. It is our goal to make sharing mobility easy and accessible through the smart charging station. So it makes us efficient and safe to transfer public transport system. And we suggest smart charging station by ground and underground type. So this charging station affect parking by climate. Let's talk about case study.
The city administration of Toronto partnered with Sidewalk Labs to create future innovative city to improve inclusive, sustainable, and quality of life. This plan consisted creating an easy and smooth interconnected transit system to make affordable transportation for people without a car. Then designs of comfortable lanes that enables people to reach wherever in the neighborhood in short time by walking or cycling and get the services they seek within 15 minutes were developed. The construction of cycling and walking network will support cyclists to be separated from the car lanes and decrease the number of accidents that are caused due to differences in speeds and related parking issues. The plan encourages bike share, e-bike, e-scooters, and other low-speed vehicle options, especially for short-distance trips. There is also a plan to making the biking and the pedestrian lane comfortable in all weather conditions by employing hydraulic heater pipes under the surface of the streets, as well as a cover above for protection against wind, snow, and rain. The Green Wave initiative is both for the cyclist and the car driver's benefit. It helps cyclists maintain a certain speed on their lanes and signal car drivers by making the cyclists visible on curbs and red lights. Moreover, pedestrians are also beneficiaries from these LED light signals for safe crossings of roads. The City of Toronto had a plan to create a parking space for almost 3,800 bikes, 190 e-scooters and bike share dogs, and 60 e-bikes. This will encourage the existing cycles as it would allow them to park their cycles conveniently and new cyclists to share bikes without worrying about where to find cycles or e-scooters nearby and how to park it with regard to the city's laws and regulations. This is also supported by a requirement of buildings to have a space for bikes and e-scooters parking.
Japan is a country known for its many legacies, from cup noodles to robots. However, when talking about smart cities, some say Japan may have fallen under the spotlight behind countries like China. Though some might argue, one reason explained it is because what differentiates Japan is that it's not viewed as a smart city of progress, but rather a smart city that is already up and running. With that case, let's take a look at what innovations the capital, Tokyo, has to offer and inspire. One area we could learn from is how they deal with smart mobility. As Japan looks for the ideal way to optimize the transportation method, Docomo Bike Share is an experiment of rental bikes in central Tokyo done by the company Docomo, the country's largest mobile carrier. Their approach for this was a social-driven rather than a profit-driven one, as they wished to find an environmentally friendly way to solve a social issue and minimize carbon dioxide. One of the key drivers for the project was the expansion of GPS technology and smartphones. With that, the users can find the stations, usually found at convenient locations like parks, convenience stores, or near train stations. Available parking as well as start and end a rental. The GPS also helps track bikes with low batteries. One of the biggest issues with bike-sharing innovations is illegal parking and cluttering, especially for Japan being more culturally sensitive than other countries in, for instance, Europe. And although Docomo has designated parking spaces for their bikes, it becomes an impossible model to scale, and the fear for bicycle burials, as what happened in China, arise. To solve this, EcoCycle set up proper storage units for bicycles where traditional storage methods were inadequate. The company Geeken provided a robotic parking system which stores about 204 bikes each, which one can be retrieved to the user within 13 seconds. The space measured to be about 8 times 11 meters below the street and are earthquake resistant. Being underground, it also keeps the bike safe from harsh weather and theft. With this high volume and density, it minimizes spatial footprints, promotes cleaner spaces, and more opportunities for green spaces. So with the increasing popularity of eco-friendly mobility, for future innovations, Japan should first recognize bicycle sharing as a public asset instead of a social experiment. Secondly, electric scooters are recently grabbing attention and is planned to be released as a next-generation transportation method in Japan by this year. The goal is to provide a safe vehicle for all ages by being lightweight and easily adjusted when it comes to speed. However, the challenge within this is that electric scooters are considered a motorbike in Japan, thus one needs a license to ride one, which limits its scale of users and accessibility. Nonetheless, the case of sharing mobility in Japan can teach us a lot about what to consider, how to further and better implement it into our campus today.
Let's take a look at site analysis. In Seoul National University campus, students can take city buses and shuttle buses. However, many students have to walk most of areas in campus since there is no transportation going through the campus. Especially Guana campus is located on the mountain. So the slope of the road is very steep and the distance between the buildings is quite long. And these factors make students more difficult to move around the campus. Especially, let's look at the shuttle buses in Gwanak campus. They are divided into clockwise, counterclockwise, and late-night shuttles. The shuttle bus is free of charge, but the time and distance to the destination is very long. For example, if you miss the clockwise shuttle bus in front of your eyes, you have to wait for another 30 minutes to take the next bus. Therefore, from time to time, students want to use other mobilities rather than shuttle buses. Let's suppose that you want to go from a dormitory to First Engineering Center. As shown on the left, if you use electric scooters or bicycles, it only takes 4 minutes to go there. However, when using the shuttle bus, it takes more than 20 minutes. Therefore, electric scooters and bicycles are good alternative mobilities for campus. Students could save the time and energy by shortening the distance. They are also eco-friendly transportation using electricity. Moreover, from December of this year, it is expected to be easier to use because it is going to be available legally without a driver's license. Since various advantages exist, the demand for electric scooters and bicycles is increasing. However, behind the convenience, regulations related to students' safety are still lacking and infrastructure needs to be managed. First, let's look at the problems when using shared bicycles on campus. Most of the students use bicycles operated by the city of Seoul, which is Tarini, because the fee is very cheap and it's simple to use through the application. However, as you can see in the photo, there is no rental office on the campus. Therefore, students are experiencing inconvenience in using bicycles because they cannot rent or return them on campus.
Next, let's look at the problems when using the shared electric scooters on campus. In general, after borrowing an electric scooter through the application, students can leave them at any location on campus. However, as you can see in the two photos on the left, the number of electric scooters that have been neglected and parked indiscriminately has increased. These electric scooters spoil the beauty of this campus and obstruct student mobility. Also, because the shared electric scooter is powered by an electric battery, students can use them at night since the battery is low. Finally, we propose building a charging station for electric scooters and bicycles as a solution to enable students to use vehicles comfortably and freely. The construction of a charging station on the campus is expected to have the following effects. First, it restores the aesthetics of the school and helps students to pass smoothly by collecting the randomly parked electric scooters from one place. Second, it is possible to charge the battery through a charging station, so students can use a fully charged vehicle at any time. These ideas can also be applied to the newly built SEAM campus. They are corresponded to strategies of SEAM campus master plan. Among the various strategies and plans, there were several strategies that were related to the means of transportation we presented earlier. First, SEAM campus aims for a smart link that connects space, buildings, and people on campus and between campus and city. Alternative transportation such as electric scooters and bicycles will strengthen the connectivity by reducing the amount of time and distance needed between areas on campus. The second strategy is Smart Ring. SEAM campus aims to minimize vehicle entry and promote eco-friendly transportation. Electric scooters and bicycles are representative transportation methods for the environment that use electricity. The third is Smart Mobility. SEAM campus strives to create a pedestrian-friendly space. For these three strategies, Electric scooters and bicycles will be good means of transportation, and the suggested infrastructure will be needed. In addition, as a smart campus, CN Campus is planning to manage various infrastructures, including facilities and energy, etc., through an integrated SI system. The SI system will help to manage the overall transportation system and collect user data. Also, electric scooters and bicycles can be a good means to collect user data and inform more detailed traffic condition in real time.
This is the concept what we want to show. First one, we make smart charging station for e-scooters and bicycle. The smart charging station will provide charging during parking time through solar power. According to road type, we want to make new paths for smart mobility. Finally, we can suggest integrated measurement system. This system collects user data and analyzes traffic through real-time monitoring. It can be more helpful for monitoring past situations and improving infrastructure. So this is what we will do. First, we are going to find right spot in our campus and then evaluate its adaptability. Second, we suggest station scenario by each road type. Finally, we imply which campus will adapt this system. Thank you for listening, and I hope you understanding our team project well.
Hello, our team project title is Application of Smart Waste Management to Smart Cities. Our contents include the introduction of waste management, case study of smart bin, case study of autonomous trash sorting robot, 3 candidate cities, and conclusion. Every human is producing waste, and we think that until the last man survives on the earth, he will also produce waste. It's one of the major problems of humankind. Increased waste in urban areas has affected on sanitation facilities, water supply, health, and so on problems. Waste management is intended to reduce the adverse effects of waste on human health, the environment, and aesthetics. Waste management includes the activities and actions required to manage waste from its inception to its final disposal. Waste management process include 5 steps that waste collection, transport, segregation, recycle, reuse, and disposal. Technologies have made significant progress, but most technology and innovation focus on waste recycling, reduce, reuse, and waste disposal steps, such as biological reprocessing, energy recovery, and pyrolysis process. But for the waste collection, transport, and waste segregation steps, they are still function as it did 30 years ago. It's not really smart enough for now cities. For our project, we will focus on combining waste management problems with smart technology and innovation, such as IoT, big data analysis, AI, robotics, and so on, and try to find out a new smart waste management system. Waste management is an unavoidable challenge in today's smart city, and it's also a problem that people in the city can experience in their daily life.
As we know, the biggest problem in waste management is separating waste. In this case, technology plays an important role. We promote cases with separating and technology keywords. The first case we promote is a smart bin. Why smart bin? Problem in separating waste is a big issue. Currently, technology cannot separate all type of waste properly yet. That's the way separation of waste is still an important thing to do to speed up waste processing. Not everyone is familiar in separating garbage, especially for foreigners. So we need media to literate how to throw the trash in the right bin. The trash bin must be smart. It can inform the remain capacity and location of the trash. Smart bins have implemented in some countries, like in Melbourne, there are 2,500 public litter bins and 400 solar smart bins installed. In Singapore, they use smart bin with solar panel called as a big belly bin, with capacity 5 times the normal bin. Poland is the first developing smart bin in the world, which named Bin A. The smart bin utilized by combination of sensor, image recognition, and AI, and equipped to compressing system. Let's take a look more detailed smart bin. The smart bin has a big display to educate users separating the waste. It can show the video which contains how to separate the waste. The bin uses Wi-Fi as power source and equipped by compressing system in order to accommodate more trash. The remaining capacity of the smart bin calculated while compressing system work and informed to center of waste management system. The business opportunity will be available since the smart bin generates much data. There are some benefits by using smart bin. Garbage collection visit can be reduced. That means lowering the emission of carbon dioxide and other gases. Using a gentle compaction system, maximizing bin capacity. The smart bin have been standardized in a way to use existing equipment. Smart bin increase recycle rate. Smart bin take up less space on the footpath and make people easier move around the city. It can create a new startup that produces smart bin and a new startup by utilizing and processing data that generated by smart bin sustainable development. What if the smart bin is implemented at the Siang campus? In my group opinion, the Siang campus has many international students who are not familiar with how to separate the trash into the bin. So, smart bin can teach them how to separate the trash. The smart bin will become one of the living labs in waste management system and innovate over time. The data generated by the smart bin can be processed using a big data analysis and AI and creating a new startup for convenient of resident sustainable development. And the Siang campus will become a living laboratory for waste management.
Second case, sorting robot. As the city growing, the trash amount also increased. Many countries are choosing landfill or burning, but it is not a ultimate goal for the disposal trash. In United States case, 6 to 8 million of ton recycling waste cannot be recycled because it is not sorting well. But the critical problem is people does not want to sorting jobs. When China changed their recycling trash import standard, the effect spread many countries. Robotic technology is one of the essential technology to solve this problem in smart city, and we expect it can increase the recycle rate. As you see the left movie clip, this is a prototype of sorting robot. When using this robot, we do not need a human resource at this job. Second, as many people concerned about the sorting rate, but AI or deep learning, we can increase the sorting rate. Google case with this robot, they reduced the waste rate on their office from 20% to 5%. Furthermore, we can expand this mechanism to other places. As right bottom of picture, we can use this mechanism sea or river cleaning or stadium or concert cleaning. How we apply this technology at Siung campus? We can expect two cases. First, we hope that Siung campus crowded with many companies, such as startup or venture, like Google. Robots move around the office and sort recycling garbage. It sounds like complicated, but it is easy to understand that you have robot vacuum cleaner and it has recycling classification function. The second application is collect recycling garbage in one place then sorted by robots. The robots simply sorting recycling job rather than by human.
We have selected 3 candidate cities to apply the above technologies: Bangkok, Jakarta, Moscow. These places had a common problem of not having a waste collection process. First, Bangkok. Thailand is the 6th most polluted country by plastic in the world. There's no waste disposal system here, and the increasing use of goods by tourists every year is becoming a problem. Next is Jakarta. Jakarta lacks waste disposal facilities, and half of the household waste is being illegally incinerated. Currently, Allianz Life is increasing active participation by creating a waste bank related to insurance products. System design is required for waste screening and disposal by combining with the waste bank. Finally, Moscow. Russia can recycle 40% of its waste, but only 10% of its total waste is recycled. The problem is that there is no concept of segregating waste from primary waste sources, such as the regulation garbage bag. In the end, waste separation is achieved only after private businesses collect waste.
Conclusion and further study. Our team noticed that increased waste in urban areas has affected dramatically on the environment, such as sanitation facilities, water supply, and health. Unfortunately, the waste collection, transport, and segregation process still didn't function well, so we focused on finding waste management innovation technologies such as IoT, big data analysis to enhance the waste collection, transport, and segregation process. We found 2 cases. One is a smart bin and another is smart sorting robot. Both can be combined and applied to SNU campus. Limit can operate properly by educating people, and central management processing using big data and sorting robot will make applied areas smarter. In addition, 3 candidate cities of practice were selected, and 2 appropriate places to be applied are going to be selected so that further investigation can be conducted. It is necessary to consider feasibility of sustainability in the long term. We believe that the smart waste management system will be of great significance in sustainable development of smart cities. Thank you for listening.
Contents include introduction, collecting waste, generating electricity, conclusion. The movement to smart city is indispensable, and waste must be managed smartly. That includes smart collecting, smart sorting, smart compactor, and underground container to use the waste as energy source and recyclable resources. Smart trash can senses the amount of waste, compacts the waste using solar energy, and uses IoT technology to send an alarm to manager. For example, in New York and Seoul City, we expect to reduce pickup costs and prevent overflow. An additional program might be providing Wi-Fi to citizens, public service advertisement. However, there are several issues to implement smart trash can in the aspect of energy and sustainability. So we researched the individual cases for integrated system. That includes smart collecting the street and household waste to prevent overflow, smart sorting to reduce labor, smart compactor to save space, and underground container to avoid smell and harmful insects and rats. From suggested idea, we can generate new industries. We can implement this plan in SNU campus. As the campus is private area, traffic law will not be applied for unlicensed vehicle, like mobile smart trash can. To implement that in smart trash can, autonomous driving system and computer vision technique can be applied. Moreover, smart campus could be the role model for the smart city. We can conduct actual practice in Busan Eco-Delta City. As the city is designed for robot use, integrated system can manage streets and houses.
We believe that in Shihun City and all the other smart city projects, there must be waste-to-energy power plants because there are a number of reasons. First, waste-to-energy concept has a negative value for the resource materials, meaning that all the other power plants, such as coal or gas-based power plants, they pay money to receive the resources to generate electricity. And renewable energy projects, they invest significant amount of money to build the power plants, and after that they use the resource materials for free, like solar radiation, water, wind. But waste to energy concept, they receive money from the waste management fee and then use that waste to generate electricity. There are many good examples of waste-to-energy power plants. We would like to use Oslo case to explain more. And this waste-to-energy power plant in Oslo City, their total capacity is 130 megawatts. And annually they generate 175 gigawatt hour electricity and 750 gigawatt hour heat. And annually they use 400,000 tons of waste, and their main revenue 50% comes from the waste management fee. The another 50% comes from selling the energy, electricity, and heat. General process to generate electricity in waste to energy power plants is similar to other power plants. The only main difference is they use waste materials, and this waste material will be transported to the combustion chamber, and the high pressurized steam will be generated, and this high pressurized steam will rotate the turbine, and turbine will rotate the generator where the electricity will be generated. And this high pressurized steam will be the main resource for the heat. And first, rubbish or waste will be unloaded from trucks, and they use these loading cloths which will transfer the rubbish to conveyor, and all the waste will be sorted out by using optical sorting system with camera, and AI technology will be used. The main reason is it removes the harmful waste, and the sorted waste will be transferred to the combustion chamber, and all this process is monitored from the control room. And in the combustion chamber, the temperature reaches 850 Celsius, which is the same as volcano lava. And after burning the waste, about 20% of the waste will be remained, and this is called bottom ash. From the bottom ash, the metals will be removed by powerful electromagnets, and 50 tons of metals are collected every week, and they will be sold to the recycling center. And these debris will be used to make construction blocks and also for roads. And all this process will be monitored 24 hours, 7 days a week from the control tower. And Oslo City, they have a plan to increase their capacity. So they want to add the capacity which will use another 160,000 tons every year, which will produce 55.4 megawatt heat, and which will supply additional 40,000 households, and additional 10.5 megawatt electricity, which will supply another 20,000 households electricity. We are proposing to implement waste-to-energy power plant in Sihon City. The capacity would be 200 megawatts. Each year it will generate 950 gigawatt-hour electricity, and annually this power plant could use 560,000 tons of waste, and the electricity could supply around 60,000 to 80,000 households alone. In order to implement this waste-to-energy project in Sihon City, we have to do the following. First, review related laws and regulations. Second, conduct cost and benefit analysis. Then make feasibility study and choose locations. The total required land for this project is 11,600 pyong. This power plant could use 5,600 tons of waste every year, and each year 950 gigawatt-hour electricity will be generated. From the bottom ash, the metals will be collected and reused. The debris will be used for making construction blocks and roads.
The four waste-to-energy concept model we developed here, we divided into two ideas, smart trash can and waste-to-energy plant. At this time, the smart trash can have some limits, so we tried to develop a better trash can with robot and machine learning technology. We developed this business model of power plant also, which generates electricity, and we anticipated an economical benefit which will be made after installation. Also, we recognize the city of Wuhan in China has planned to upgrade their power plant to be eco-friendly. But since we could not collect Wuhan city's data enoughly, so we decided to get research more information to adopt model in the future. So as mentioned at the beginning, how to manage the waste resources must be discussed to make better smart city. Do not waste the waste. Thank you.
Hello, awesome audiences all over the world. Good morning or good evening or good night. This is SCGC 15. Today, we would like to introduce our new project for two phenomena occurring in the era of smart city. The digital life aid for digital transformation and digital divide. Let's begin with this question. What is smart city? Smart city is an urban area which uses information and communication technology for solving problems in the city. Smart city bring us two contradictory phenomena: digital transformation and digital divide. Then, what is digital transformation and digital divide? Digital transformation is nothing short of total business transformation. By using technologies, we can change the way we operate to create new value, solving traditional business problems and create new opportunities by integrated technologies into all areas. Digital transformation can be realized in cities across all sectors. On a global scale, new technologies have been adopted most in the smart governance sector, while the energy, healthcare, infrastructure, security, building and mobility sectors are catching up. Make no mistake, digital transformation is a fundamental change to the way your organization does business. It's a long-term investment, and to be successful you need to rethink old operating models, be prepared to experiment more, and become more agile in your ability to respond to customers and competitors. The transition of a business with digital transformation. A lot of competition will be generated, therefore, create new value and opportunities. Recognize customers' needs and responses quickly. Adopting a digital-first mindset, apply AI to learn customer behavior and predict the expectation in the future. Evolve with the market and continue increasing value to your customers. Digital divide is any uneven distribution in the access to, use of, or impact of information and communications technologies between any number of distinct groups, which can be defined based on social, geographical, or geopolitical criteria, or otherwise. Then, why do we focus on digital divide? As Smart City adopts ICT-based solutions more and the digital transformation progresses, the digital divide will get worse. What are the city problems we face? In terms of digital transformation and digital divide, digital transformation isn't an overnight process. It will impact all operations of a city where new technologies must be embraced for efficient and effective city services and creating new values. Yet this requires a change in public sector governance and operations. Applying business models and performance metrics may be a new concept for many cities. Even though there have been many research directions in developments in urban design, still, the problem has not yet been solved efficiently since people are unable to accurately visualize and predict future changes based on a variety of changing factors in urban design for pedestrians. Furthermore, they usually cost tons of time and money to visualize a specific scenario. In an environment where digital transformation takes place rapidly, plans for natural environments that are not related to industrialization are being slow. Looking at the Smart City Plan, even digital transformation related to the environment focuses on issues related to waste management, air and water supply, which are directly related to people's lives. As climate change problems caused by environmental pollution become serious and the talk of biodiversity is constantly being made, digital transformation for environmental conservation should also be considered. What are the problems of digital divides in Smart City, especially in Seoul? Nowadays, many schools in Seoul are embracing technology. However, the digital shift of classrooms is proving to be a disadvantage to some students in low-income families. Students without having their own laptop or computer could fall further behind. Seoul has made significant progress over the past few decades towards providing services to its citizens more intelligently. However, activities as simple and basic as using touch-screen interfaces in restaurants can be challenging for senior citizens. The other big group facing difficulties in the smart system is the people with disabilities. People with visual impairments have more difficulties in using touchscreen technology. There is also serious concern that the smart technologies will only benefit a small part of the citizens and worsen the rich-poor gap. What are the potential solutions for these city problems? Firstly, we would like to begin with the potential solutions for the introduced digital transformation problems. Seoul and Sihyung have set Smart City Living Lab as a strategic method of engaging its citizens. Living Lab is a network or governance model where citizens come together to identify city problems and solve them with innovative technologies. However, facilitating the participation is difficult. Unclear goals, lack of usable interactive tools, worksheets and professional facilitators are examples of barriers to well-operated living labs. Citiscope is an undertaking led at the MIT Media Lab City Science Gathering. It combines a tangible, interactive table and digital platform to solve urban planning and design problems. They develop and deploy these tools around the world and maintain a free and open source community for the majority of our work. Urban performance indicators include 3 core modules: a physical 3D model, a tangible interactive interface for interventions, and a feedback system that computes and analyzes units. The first potential solution to environmental problems is an example of biological monitoring. The Polar Citizen Science Collective progressed the project to monitor the environment in Arctic and Antarctic. Using application, travelers participate to monitor by taking pictures and choosing what they saw. This project can create opportunities for research and public education and also enhance understanding of the polar region. Second solution case is environmental monitoring using sensors in Santander, Spain. Apart from measuring parameters at static points, devices located at vehicles retrieve environmental parameters. Sensors are installed in 150 public vehicles, including buses, taxis and police cars. Also, citizens themselves gather data and incidents that are occurring at that moment, in the place where they are using the City Pulse app. With these systems, Santander saves 30% of consuming public service energy. Like these overseas cases, mobile sensors and civil science can be used to solve urban environmental problems. Smart systems have to play a key role in bridging the gap between people, breaking down the inequality. Then, what are the possible ways to bridge the digital divide? We should find the way to solve a number of gaps in accessing and using digital services. Building an infrastructure with public-private partnerships can close the digital divide. As the cost of smart devices are expensive, we need companies to remove financial barriers to digital access. For example, Seoul will join with private companies to distribute smartphones with low-cost rates to senior citizens. To see the full potential of the smart city and its impact on the world, we must take advantage of its capabilities. Therefore, our citizens need to be educated on the benefits and value of utilizing them. Smart cities must be user-centered cities which can satisfy the needs of various groups. Government should consider the people vulnerable to the new technologies, especially visually impaired, from the planning stage of the smart city. How to design our own solutions? Our design plan consists of 3 processes. First, analyzing defined problems. Second, finding best appropriate solution use cases. Third, customizing the solutions for our city. Our team will firstly do in-depth analysis for defined city problems. In this stage, we will use city data, statistics and computing resources. Secondly, the best appropriate solution use case will be selected. In this stage, we will examine smart city master plans and solutions all over the world. Thirdly, customized solutions for the city problems will be made. In this stage, we will make a customized solution itself or a plan for implementing it.
Hello everyone, this is group 16. Our presentation title is Integrating an Intelligent Smart Transportation System in Smart City. Okay, let me start. The content is as follows. The first is about smart city and research background. There are many things about the concept of a smart city, but in the end, it can be said that the goal we are ultimately pursuing through a smart city is to smartly solve the problems arising in the city and improve the quality of life. Smart refers to the efficient and user-oriented management of the city by using big data, sensors, AI, and etc.
This is in line with the 11th goal of SDGs announced by the UN in 2015, Sustainable Cities and Communities. No matter how great technology is introduced in the city, it must be guaranteed to be sustainable. So we have considered what kind of contribution we can make under these goals, and among them we are going to focus on transportation. This figure is about the top 10 smart city use the cases. Among them, the transportation field is applying a lot of smart city elements worldwide. As of August 2020, the first and the second places are related to transportation. Even if there are a lot of driverless cars and automation, it is very important to establish a smart-based transportation base because we have to move in the end. Transportation-related parts of a smart city are the most important part, and the smart city configurations can be connected to each other based on mobility infrastructure. In the future, it is expected that there will be a transformation of the transportation infrastructure that was not expected with COVID-19. And if the high-level technologies to be developed in the future are combined together, it is expected that a great synergy effect will be exerted. In order to pursue this, a large target must be set, and various factors such as driving force, finance, and human resources must be put into ultimately achieve it. The second is about global case of a smart city. Definition has been created building upon European best practice. A mobility hub is designed and is specially organized in an optimal way so as to facilitate access to transport between modes as well as provide extra transport related and digital services. Mobility hubs will generally but not necessarily be situated at significant points on major public transport corridors as they form a critical element in supporting the role of high-frequency public transport within cities and large towns. Mobility hubs can be seen as an interface between the transport network and spatial structure of an area. Mobility hubs include a range of different components. This diagram illustrates some of the most commonly used components. Mobility hubs can be developed in a range of contexts from city centers to rural areas. There is no one-size-fits-all design for the mobility hub. Tailor-made solutions need to be created for each location using experience from other countries. Mobility hubs need to be adapted to the setting, both in terms of the type of component and their scale. By overlaying the type of place such as workplace, each area will be able to create a set of combinations which can be replicated across their area. This table highlights issues and possible combinations of components to consider in each area. So the change of purpose of public space requires consultation with many groups, including local residents, transport providers, and so on. Factors to examine with site selection include this. Yes, the next is about the Japan's smart city case. Japan planned the smart city in 2016. The Japan's smart city aim is to create new value by realizing a new society through new industries such as IoT, big data, robot technology, and AI, and building a system that highly fused virtual and real spaces in cities. And they have 5 strategies to implement smart city. Among these, we will talk about mobility. When planning transportation as a background, it was planned to make it easier for all citizens to move from the outskirts of the city to the urban centers. Therefore, they established a system that enables autonomous driving. The e-fallet is the figure is the left side is about this figure is e-fallet. The e-fallet is autonomous car developed by Toyota, and this car represents autonomous car in Japan. It provides new mobility that support people's lives by responding to various services such as movement, logistics, and sales. This car is convenient for people using wheelchairs. Therefore, the authorities plan to be used as a vehicle for athletics at Paralympic Games in Tokyo 2021. The aims of urban city is people and space are connected by artificial intelligence technology. Laboratory in real-life environments such as autonomous vehicles, robotics, mobility, smart home, artificial intelligence, and etc. The city has a load for e-fallet like autonomous car using in various ways. To use the car, the city was composed of 3 types of loads. Loads for autonomous vehicles. Second is loads for pedestrian mobility. Third is a load for pedestrian. The third is about ideas of a smart city solution. The rapid urbanization, easing infrastructures, and population growth continue to challenge the world's cities nowadays. Cities that take effort to advance and diversify their urban mobility systems and evolve their transit hubs will gain competitive edges. The mobility hub services provide a focal point in the transportation network that seamlessly integrate different modes of transportation. They are places of connectivity where different modes of transportation, from walking to rapid transit, come together seamless, and where there is an intensive concentration of walking, living, and playing. Collectively, this integrated suite of mobility services is intended to meet first last mile needs of transit user and citizen. These mobility hub services have a function as follows: provide access to various modes of transportation, to public transportation, real-time connectivity, traffic information, parking lots information, and also inform people about the possible connection and transportation system and conditions. The next slide. Advantage of these mobility hub services are consisting as follow. First, users can select travel options based on personal preference such as distance, cost, and convenience. Second, citizens can gain control over their own journey time and make adaptive choices. Third, overcrowding and congestion can be avoided, which improves citizen comfort. Lastly, the citizen can make the productive use of journey time, accessing online services as they travel. For users with disabilities, and elderly people, particularly those with visual or auditory impairments, an accessible format to an app can make their use of the mobility hub safer and more accessible. The mobility hub service is a recognizable place with an offer of different and connected transportation modes supplemented with enhanced facility and information features to both attract and benefit to the passenger and citizen. The Pacific the traffic monitoring and management also established in order to provide monitor and managing the traffic flow efficiently. This system may become increasingly important as the growing of urban population may lead to more and more cars and traffic on already congested roads at the same time. Finally, the cities also have a great opportunity as these mobility hub services may transform their transit hub into areas that will generate opportunity, jobs, attract new business, and secure investment. This in turn will ensure a greater quality of life for residents and citizens. First, let's start by discussing the mobility problems faced by Siheung. There are only three subway lines running through Siheung, a total of 9 stations, so extended public transportation is very important. However, the departure interval of buses is quite long, with an average of 20 to 50 minutes on weekday and 50 to 60 minutes on weekend. Also, the bus routes do not meet the need of residents. Thus, the number of people driving was relatively large, which also raised the problem of insufficient parking space. In order to solve the aforementioned problems, mobile big data analysis can be used to replan bus route based on the need of citizens and launch smart buses that flexibly adjust routes by time. Increase the setting of sharing electric vehicle and sharing bikes. Alleviate the lack of parking space by increasing the usage of every single car. Since many traffic problems in city originate from finding parking spaces, driving aimlessly to find parking spaces are not only waste energy but also increase traffic congestion. We propose an integrated smart parking system which integrated IoT sensors on the ground, which identify whether the parking spaces is available or not, real-time road conditions, navigation systems, and smartphone payment systems. Registered members can search for the destination through the client application. The system recommends the parking space near the destination and the route to the parking lot based on the real-time parking space and road conditions and automatically finish the payment when leaving the parking space. The last is conclusion. We know about the smart city traffic in other countries, and we thought of problems and solutions using city Seoul in Korea. As a result, while solving the problem of transportation, we aim to find a way for the elderly and the disabled to use transportation as comfortable as all ordinary people. Yes, thank you for listening our presentation.